Alright, hello class. I'm trying things just a little bit differently today. We're going into a landscape kind of mode, and hopefully you'll be able to see the Logisim screen better, and hopefully you can still see the notes, but I guess it's less important to see the notes here since you've got a good solid copy of those. So my goal in this video is to make the Logisim a bit more clear. And I pre-wrote down the first page of notes. I'm just going to talk through it. Again, this is Lecture 5. This is over Lab 5-3, which is due next week. That would be Wednesday, April 1st, I believe. Let me double check that date. Yes. And so even though Logisim supports gates with up to 32 inputs, you must use 2, 3, and 4 input gates because this is replacing Lab. Now I'm going to show you the straightforward way of implementing this, which will not get you the bonus credit. If you can reduce the number of gates, the details are in the lab, read through it, you get some bonus points. But I'll be using these chips in this lab. You can use different chips, and to get the bonus points, I think you'll pretty much have to. Also, since it's replacing a lab, every single pin needs to be labeled. So this NAND gate is coming from my first 7400 chip. This would be pin 3. And this might be pin 1. These two could be swapped. That's the idea. And I'm going to do this in the video. This might be a rather long video, but you can kind of fast forward and jump to things as you need to. If I'm covering something that you've already got, like if you understand how to do the truth table, then you can skip ahead. And as always, I'll post a scan of the notes, and I'll post the Logisim file once we get it completed here. I'm going to do a different problem in the lab. I'm going to do hello 1, 2, 3. That's what we're going to display as we count through these values on our switches or our inputs. So you fill this part in. From the book or the 74138 data sheet. This part you fill in CPEN 3700. Only I'm going to do hello 1, 2, 3 in this video. That's for the top half. This is the same as top. So this is your expected results. And here's your actual results. So when you do everything right, they're the same. But here's what you fill in for your expected results. So I've made a little mark here of the 7 segments, so I can hopefully rather quickly fill this out. 0 here, 1, 0, 0, 1, 0, 1, 1. B is the top right. Yes, no, no, no. Yes, 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 yes. C is the bottom right. Yes, no, no, yes. Oh, whoops, bottom right. Nope, again. Yes, yes, no, yes. D is the bottom. No, yes, 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 no, yes, yes. I haven't worked this out ahead of time, so hope I do it right, but if not, you get to see some debugging in this video. What's more important is that you're seeing the process. I want you to learn the process of how to do this. because your problem is going to be different anyway. And G in the middle. There we go. So, truth table is done. That's, throughout the semester, you always start with the truth table. When we get to the next topic in the next chapter, we're going to start with something called a state table, which is still basically just a truth table. You've got to know where your ones and zeros are going. And then from there, what do we do next? Well, we can put down the midterm numbers. I'll call this page 3. So, I can say A is equal to the sum of the midterms. 1, 4, 6, 7. B is equal to the sum of the midterms. 0, 4, 5, 6, 7. C is equal to the sum of the midterms. 0, 4, 5, 7. D is equal to the sum of the midterms. 1, 2, 3, 4. 6, 7. E is equal to the sum of the midterms. 0 through 4. And 6. F is equal to sum of the midterms. 0 through 4 again. And that's it. And G is equal to the sum of the midterms. 0, 1, 6, 7. So now what I need to do, this is an active low decoder, so maybe pause the video after I ask you this question and think about it. When I'm doing a sum of midterms, do I use a NAND or an OR gate with active low decoder? Okay, so answer is NAND. So just a rough sketch. Here's what segment A will look like. 4 input gate has 1, 4, 6, 7. B I'll do it like this. 0, 4, 5, 6, and 7. That's one way to do it. It may not be the best way. But anyway, that's the idea. So I'm going to take this now and put it into Logisim. Apologize for the delay here. Thought I was more ready than this. So when you pull up the starter circuit, it's going to tell you that there's a circuit missing, and you find it from the following dialog. And let me just pull up this whole thing. I had a test problem on the screen that I couldn't bring up. Alright, we'll do this. Alright, I think we should be good to go now. I'm going to zoom in. Hopefully this is a little bit more visible now. Got to get my notes out so I can see what to build. Get it lined up. All right. So, starter circuit, it'll tell you that something's missing. That's the 74138 decoder circuit. Locate that you should have also downloaded, select it, there it is. The enable lines, you set like that. Not doing anything else with the enables. You may think of something clever to do with the enables. If so, have at it. Again, I'm showing just one possible method for how to solve this problem. We're going to need a 7-segment display. That here. Sadly, mousing over doesn't tell me what's what, so I'm going to have to look it up. You can go here to the input output on the library reference, 7-segment display, and here it shows you where each pin is connected. So this pin here is pin A, or segment A, I should say. And we said segment A is 1, 4, 6, and 7. So I need a NAND gate. Narrow, 4 inputs. One, two, 4. Six, 7. I'm going to move things over because I know I'm going to need more space. There we go. And I'll grab my truth table here and make sure the video is still aligned. Video looks like it's still pretty well aligned. So, on input 0, 0, 0, segment A should be off. Good. 0, 0, 1, it should turn on. It did. 2, 3, it should be off. And it's turning on. Let's do 4. It's on for 4. Off for 5, that's correct. And then 6, it's off, and 7 is on. I think I've got my bits in the opposite order. I don't know why I did that. Let's do it like this. That's 7. I was claiming this was 6. That's actually not 6. Let's put these in an order that we can. So you may want to make this change as well. Change each of these to east. And that's 0, 1, 1, that's 3. So that's right there. So that's good. And 3 should be off. So I'm confident now that it matches with my truth table. I'm reading it from top to bottom. I had it from left to right. This decoder is weird the way it uses C as the most significant bit, so I wired things up a little bit strangely. Just keep track of that. I got to pay attention to details and notice when something's going wrong. All right, B. 0, 4, 5, 6, 7. Oh, wait. One other thing to do here. Like I said, everything has to be labeled, so this I'll label here. And this is a 4 input, so it's 7420, number 1. Now that's big, so let's change the font size. And that fits inside. That's good. And now I'll put a text here. What pen is this? So I've got to pull up my lab guide, or we can look at Appendix D in your book. And we're using pens 1, 2, 4, and 5 as inputs. And again, I'm going to change the font to be something small. Apparently it's going to make me change it every single time. And I'm not going to take these. Well, like I said, I didn't do this ahead of time. If you want to print out your circuit and then write this all in, I'm fine with that. But either way, it's got to be labeled. Just having all kinds of trouble here. There we go. Grab that guy. 10, 4. 5, and then the output pin on this chip is 6. So there I just did a copy and paste, and there it is. Don't have to label pins on this because there's all kinds of different 7-segment LEDs out there. Don't worry about that. All right. So need that kind of detail because this is replacing a lab. You even need to label pins over here. label your switches. It's a 74138. Label it. Alright, I'm not going to label anything else, but just know that you need this level of detail up here. And we'll do a couple more. We may not do the whole thing. Let's look at B now, because this one has 5 that we've got to use. So which one is B? It's this guy here. And what I'm going to do is make this a 2 input. And I've got 5 total min terms that I need, so I'm going to do a 3 and a 2. There's my 2. I'll make that a 3 input. It really just kind of struck me, a better way to do this would be to take all these gates and face them downward. So let me just restructure this so you can see what I'm talking about. I don't want to be undoing a bunch of work here. No. There we go. Move my pin numbers. Thank you. It's worth this effort because it's going to be a lot cleaner to do it this way. I'm just going to have to delete a bunch of stuff. So now for segment A, which I believe was right there, we had 1467. 1, 4, 6, 7. Have these all face south. There's B. To make this work with the NANDs, we need inverters. And that's what I wanted you to see, how to make a 5-input NAND gate from 3s and 2s. So, which min terms we have for B? 0, 4, 5, 6, 7. 0, 7, 6, 5, 4, 5, 6, 7. Whoops. 7. Alright, so segment B should be on for just run through the combination. 0, it's on. Not for 1. Not for 2. Not for 3. Should be on for 4, 5, 6, and 7. So there. Assuming my truth table is right, which I did it very quickly, might have mistakes. Let's do another one. At this point, you could probably stop the video, but I'm going to go ahead and roll to the end until I finish this whole thing. We have a 4 input gate. Again, all your pin numbers must be labeled here, all your chip numbers. Alright, where is segment C on this thing? And that's down here on the bottom. Okay, C is 0, 4, 5, 7. 0, 1, 2, 3, 4, 5, 7. D has 6 terms in it. Copy and pasting to save myself some time and effort. This one should be a 2 input. Boom. And let's see, segment D is second from the left down here. We need 1, 2, 3. 1, 2, 3, 4, 5, 6. 4, 6, 7, excuse me. 4, 6, 7. Alright, 3 to go. E also has 6 terms. So I'm going to copy all these gates. And just do that again. And I got to figure out where E is on this guy. Lower left. And so we need 0, 1, 2. 0, 1, 2, 3, 4, 6. 3, 4, and 6. And there we go. That's E. F has 5 inputs. A, B, C, D. So it's this one, so it's second from the top left. go ahead and cross over here, not neatly. Alright, so F is 0, 1, 2, 3, 4. 0, 1, 2, 3, whoops, 4. And G is 4, so that's easy. We'll need to extend this out a bit. And it's 0, 1, 6, 7. 0, 1, 6, 7. And G is the upper left. So you can already see there's a problem with 3. But let's test everything. H. That should be E. Should be L. L. O. One. 2, 3. Oh, there's a problem right there. Oh, okay. Yeah, I see what I did. Swing around here. Hopefully that's the only problem. There's a 3. That's good. All right. H, E, L. So we got a problem here. So we can pinpoint the exact point of this problem. It's input 0, 1, 1. And it's segment C. And then 1, 0, 0, seg C is also wrong. I can already guess what the problem is. 1, 2, 3. So I would say that I probably swapped a couple things. And my design is probably right, but let's look. I probably just flipped a couple wires here. So A, B, C. I'm looking at my truth table here. The ones in question were this one and this one. So I probably took min term 3 instead of min term 4. 1, 2, 3. No, right here. 0, 1, 2, 3. Yeah. That should move there. Now I got my 0. I've got my L. So that fixed it. could even make these more compact by saying just 5. Just put the pin number. But just some kind of label. You've got to have everything labeled here as well. So again, this is not the extra credit way of doing it, but it's a straightforward way. I did this, you know, I mean, granted I'm teaching, but I made up a brand new problem and it didn't take me too long. If you follow the video, follow these steps, you know, you can do it this way if you want to get the extra credit. You know, you'll have to think about it a little bit. And I'll say you will need something other than NAND gates. But this is the basic way to do it. And you can still get an A doing it this way. But again, label every pin. Label your switches. Here, you don't have to label these as switches. They're just hardwired, ground, and 5 volts. If you want to in your circuit, you could even replace them with that and that guy times 2. Alright, that's it. Let me know if you have any questions. Hopefully this video is a little bit clearer on Logisim's side, at least.